Find old junk, poke at it.
Yeah, step one, find old junk.
Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Tom Nardi.
This is episode 241. This week we'll be talking circuit bending, resistor filing, the butterfly keyboard, and the big badge reveal. This week in Hackaday News, big badge reveal and the second round of talks. Both came out. So now those of you who have Supercon tickets, you should be getting excited. Those of you who don't have Supercon tickets, it's sold out. You should be getting on the waiting list.
Wah, wah, wah.
Well, I mean, what are we? We're 2 weeks out as we record this.
That's true.
Less than 2 weeks when you are listening to this live.
Yeah, I guess if you hadn't gotten a ticket by now.
Yeah, and if you missed out this year, A, there's always next year, and B, there is always the video streams. We'll be streaming everything we can live, and what we can't stream live, we'll write up for you later on Hackaday. So at least the talks you won't miss, but all the cool stuff that goes on in the alley, all the fun hacking, that you're going to miss. There's just no substitute.
This is true.
And you'll also miss the badge, which came out this week, and we'll be talking about the badge in the end of the show.
Yeah, if you waited this long, you can wait the rest of this episode to hear more.
That's right. Yeah, badge production, a little bit late this year. We'll talk about that when we get down to it. Before then, let's hit up What's That Sound?
This is a journey into sound.
What's that sound?
What's that sound?
This is a record What's That Sound? Most people answered, and I think most people got it correct. And I think also probably highest percentage of people got it correct, which is to say it was too easy. Sorry about that, y'all.
All right, I'm going to listen, and I will try not to fail. The pressure's really high on this one. I mean, you really talked it up, and then...
Even Dan Maloney got it.
Oh, well, I'm not sure how to take that. All right. Let me listen. Oh, all right. Well, that's oh no, it's Zelda, right?
Uh-oh.
What is it? Ah, man, I knew it. It's one of them silly NES games.
You're in the right neighborhood.
Not Zelda. It's not like you found something Zelda noise.
You definitely found
Mario. When you get to the end of the level.
Bingo.
Okay, man.
There you go. Whew, thank you.
Yeah.
You saved me.
I knew I knew it, but it was deeply buried. But not a memory I've had to use very often.
Yeah, exactly. Dan was like, "Oh man, I don't know this one at all. It's some old video game. Maybe it's like it's some old video game. I'll never get it. Like Super Mario Brothers or something." And I'm like, "Yeah, thanks, dude."
But I think like the finding something in Zelda has a similar cadence, right? They probably copied each other's notes back then.
Might well. Everybody recognizes it as like the success sound, right?
Right.
But this is the one where you clear out the level in Super Mario. You jump on the flagpole and you like swing down the flagpole.
I think there's little fireworks over the castle.
With fireworks, exactly. Our descriptions of this from the 107 correct answers. 107 people answered, 107 of them are right. So this is like
wow.
This is like the test of the emergency broadcast system or something. This is how many people are willing to write in and get a Hackaday podcast t-shirt. Thank you all. You beat the level noise. What else? Oh, nice. Retro Game Club podcast. Super Mario Brothers level clear theme. I predict you'll be rolling 100-sided die at least. Not bad. I think just for that alone, people, at the end of Super Mario after he jumps on the flagpole, I finally guessed one from that Beetle guy. Congratulations. Finally getting past the broken steps at the end of Super Mario Brothers with no time to spare, therefore not receiving any bonus points after sliding down the flag. Somebody's a little bitter. A little Italian guy hoisting a flag on my first console. I'll give you that one.
Well, all right. Accurate.
I'll give you that
Strangely
one.
accurate.
I went looking for the sound for this, and I accidentally downloaded the "You Finished the Game" music by accident, and I played it, and I'm like, I've never heard this music before.
I was gonna say,
What's going on
I
here?
never got there either.
Yeah, exactly. So I've determined that I haven't ever gotten to the end of Super Mario. It's a long piece, but the level clear one is the one I meant anyway. So there you go.
I think everybody just gets to like dun like the second level.
Oh,
and then they're like, I've seen enough. How many mushrooms can you jump on, right?
Yeah, right? I think I've played at least through that one, but probably not past like 4 or 5 levels. I don't know. As a kid, I played more Mario than as a grown-up.
I don't think, now maybe the Mario super fans will come out of the woodwork, I don't think I've ever heard that jingle since. It's not like it has become part of like the Mario identity, you know what I mean? Whereas like a lot of the old games still they still use riffs from like the original sound. Like Zelda definitely like uses similar sound effects from the original one, although, 30, 40 odd years improved. But you could still kind of go back to the original Zelda and be like, oh yeah, I recognize that sound effect. I don't think they did that with Mario. I think they just kind of... They made that song one time, and they're like,
It's too short. What are you gonna do with it? How are you gonna keep?
Right.
No, the one that's
Yeah, like that. I recognize. I identify that more with.
That one's solid.
Yeah.
Yeah, okay, fair enough. Anyway, 107 people got it right. I am firing up the National Institute of Standards and Technology randomness beacon, and asking them for a random number, and I get 50. Okay, now I have to go look. Spreadsheet number 50 is... Congratulations to Nervous Pajamas. Finally getting past the broken steps at the end. Oh my God, that was one of the ones that I liked. And entering the castle, the mumbled swearing of an 11-year-old is optional. Whew. I think that's also the longest. Oh, no, only the second longest answer. But it was the one that the random number generator picked. So congratulations, Nervous Pajamas. I'll get in touch with you and get you a Hackaday podcast t-shirt.
Calm your pajamas. You now have your own t-shirt. Nothing to be nervous about.
All 106 of the rest of you tune in next week for a new sound and a new chance at winning the Hackaday podcast What's That Sound contest. All right. Well, I wanted to start off the hacks this week with a video from Learn Electronics Repair. This is burnt resistor sleuthing. And I think I mostly wanted to cover this because we take resistors for granted, and it's time to not take resistors for granted anymore. The backstory here is that he is trying to fix a broken circuit board and it's got a burnt resistor on it. You say you desolder it from the circuit board, you pull it out, you want to get a new resistor to replace it, you put the clips across it and it reads open circuit because the resistor itself is broken. What are you going to replace it with? And the answer is, well, if you can find the data sheet, you just get the right resistor. But if you can't, you are stuck. And your last resort here is what goes on in this video, which is he grinds off the ceramic outer coating, exposing the thin kind of wrap of metal foil that's inside a resistor. And that's partly why I like this video, just because I think that's really cool. If you haven't taken apart a resistor, with a file or with a Dremel or with sandpaper or whatever, you absolutely should, just to see what's on the inside. Or you could just cheat and watch this video. So his trick is that you kind of just put a probe tip basically in the middle and on the end, and you can assume that's half of the resistance value, right? And so he's doing this with one that he knows to be, I think, an 18 or 1.8K or 18K resistor, and he gets like 7.5 in the middle, and so he kind of figures out that it's probably that value. You're not going to get super accurate with this, but you can get at least in the ballpark. And the other approach he takes is to, again, it's wrapped like a spiral around this core. If you even just have one wrapping that's contiguous, if like there's a crack that goes the long way down the resistor, you can at least test 2 wraps that are like right next to each other, so you can figure out how much resistance there is in one wrap and then just count up the wraps and multiply that out too. I don't know, it's like a very fundamental way to look at resistors and figure out if you're really up Shizzle Creek like this guy is apparently, and you need to figure out the value of a busted resistor, you're actually not ruined.
definitely an old school technique because, I mean, how many of us are still working with the through hole resistors, right? But it's still, like you said, a very cool fundamental thing. And I guess if you're doing repairs,
Yeah.
you know, if you're doing new designs, well, you'd probably know what the value of the thing would be anyway. But if you're doing repairs and you're finding something in the field that's been kicking around for a couple of years, there'll still be through hole resistors for some time yet in weirdo gadgets. So it's definitely like you said, a good technique to kind of have in the back pocket, and an interesting practical lesson. How these things are assembled. And then, of course, in the comments, people are like, "Oh, well, it'll only work on this, that, and the ones that it won't work." And no one's suggesting this is a everyday thing.
Probably true.
I mean, I guess you lucked out because you didn't have the diagrams or anything in the first place, but you would need a little luck for this to give you useful results. But I think, like you were saying too, maybe just grab a resistor, now. Before you need to use this technique, just get a resistor now and file one down and poke at it and see if you can't come away with a little bit more knowledge than you came in with.
And I actually wanted to link in here an article that I wrote a million years ago, more specifically back in 2017. Hackaday trims its own resistors, because I read somewhere online that you could take a file and file into the spiral wind inside a resistor and vary its value by actually trimming it with just a regular old metal file. I actually was doing it for a synthesizer project at the time that needed exactly matched resistors. And, I had 1%, 5% parts. I can't remember. Actually, I think I was pretty good anyway. But then I was able to trim these down. They were 2000 ohms, and I was able to trim them down to the ohm,
Oh, wow.
So that was really pretty cool. And I got to do basically the same experiment except in reverse. You file it down, taking as little as you can away, and then you just thin it down just the tiniest bit until you get exactly the resistance you want. And of course, this only works if you're increasing the resistance. It wasn't really very easy to decrease the resistance. And like you say, it's totally useless on surface mount parts. I actually tried it at the very end of the article. I link that in. I tried with a surface mount part, and it actually, when I started filing on it, the resistance went down a little bit because I think I must have been dragging solder from the solder joint onto the surface, and then it just went catastrophically up. It was just horrible. I tried 2 or 3 of them and couldn't get a single one to work. But with the, normal big through-hole wire-round resistors, I got every one of them to work within, down to the last measurable digit on my scope. So I was pretty happy about that. And then actually somebody said, but how are they going to age? And so I put one of them I covered with nail polish, and the other I didn't cover at all. And I put them in a desk drawer, and I just left them there. And I think I came back 2-3 years later and measured them again, and they were both exactly at 2000 ohms. Actually, I have to scroll down into the comments here and see if I can find my own comment on this, because I'm pretty sure that neither of them changed.
You can go look for the resistors. They're still in the drawer somewhere.
They are still in the drawer somewhere. I actually looked for them right before the show and I couldn't find them. So I don't know for sure. Let's see. Okay, Tom reminds me. There we go. Elliot in 2018. I said I was going to test them again, and here I am doing it. No measurable drift on the coated or uncoated, trimmed or untrimmed resistors. Oh, I left some of the stock ones in there labeled as well. Oh, good for me.
The control. There you go.
Yeah, as a control, huh? That's
Of
freaking
course,
ladies and
Yeah,
gentlemen.
right.
You
That's
go
the scientific
me.
method.
Yeah, damn straight. Anyway, I thought it was a pretty weird thing to do. Unless you're making precision matched analog DAC with a bunch of resistors or something, which is what I was doing at the time, you're never going to need to do this. But if you do need to, you can, and it's just dead easy.
Well, it's funny you mentioned about matching the resistors and changing their value. I think it was an EEV blog video where he did a teardown of one of those super accurate resistor decade boxes or whatever.
Oh, yeah.
And it's basically just banks of through hole resistors in there that you switch in and out of. And he was taking it apart and he was like, why does the solder work so ugly? There's so much solder on here. Who was it the intern's first day or something? And then in the comments, they said they would do that to fine tune it because they would put more solder on it. They would just dump extra solder on where they needed to do very minute changes, and I guess didn't want to break out the file and file down the resistors, but that's how they got that super accurate result, by adding and subtracting solder where technically not necessary.
Oh, see, that's awesome. I like that sort of stuff. And, the truth is it's dead simple to do this sort of thing. You never need to. And like, if you have to do this in production, there exist laser trimming machines that'll do this for you as well. But, it's funny when you can kind of, through these like ultra low tech methods, get either, in the case of this repair thing, get some information back that you thought was destroyed, or in the case of trimming the resistors, you can just get like ultra high precision. And all you're doing is like sawing at the thing.
Well, for my first hack of the week, I picked restoration of a ThinkPad 701C. And even if you don't know the number by heart, there's a good chance you've at least seen this ThinkPad online before. This is what they often call like the butterfly ThinkPad. You open it up and the keyboard does this really crazy like shifting left and right to get bigger. A marvel of technology that, surprise, surprise, they didn't continue because, the mechanism involved, I imagine, is very unpleasant. I gotta say, I kind of misjudged this one at first because I said, this is a video from Polymat, and he's gonna restore one of these ThinkPads. I'm like, okay, sure, you gotta wipe it off, put a new hard drive in it. Like, what's the restoration gonna look like? But I was flabbergasted watching this video because it is like, if this was a car, this would be like the off-frame professional restoration. Like every piece of this thing is redone. I mean, to the point where he takes it apart and strips all the paint off of the frame, like you would do, like a car. Like he strips all the paint of it off and then repaints it, and then has new decals made that he puts on, like for all the caps lock light and the battery light and stuff. Like it is really, really an incredible rebuild. Like everything is touched up or improved or buffed. I mean, even the connectors in the back all get like polished with like a little toothbrush and stuff. And then he's getting towards the end, and he puts a new battery in there, and he holds the battery up, and it's got his logo on it. And I was like, wait a minute. So I go on there. He's making new batteries for this thing. He has a website called Project Butterfly, where he's actually like making new parts and releasing documentation. It's all open source. And I mean, he really, really loves this ThinkPad because I mean, he's gone through incredible lengths to make a community for bringing this thing back to life. And I think they are pretty rare to begin with. So I could imagine finding parts wasn't easy beforehand, but he's got PCB files, STLs, like a documentation. If you ever come across one of these things, or I mean, if you've seen them and were into it and wanted to add it to your collection, the information is out there. Like don't worry, you won't have to hunt around on some old forum to find this, because he's done an excellent job of curating all this info and putting it out there. And I mean, I guess if you're going to pick a computer to obsess over, you could do worse than this one.
That's funny. A friend of mine way back in the day, I guess he had a busted 701, and he took the keyboard out and he wanted to make a portable keyboard for himself. And so he like detached the keyboard and made a little frame for it so that he could fold it back in on itself like cool. that. I don't think I ever got to see the finished product, now that I think about it. And that makes me horribly sad.
So I was out of curiosity, I checked eBay. There isn't even one for sale currently, but the last one sold for $410. So yeah, Ew. They're pretty valuable for old computers.
Well, the keyboard mechanism is rad.
I mean, that's
like that right? alone. Like,
yeah. Because I think it's a 486, right? I mean, this is ancient. This isn't even like, I'll grab an old ThinkPad and put Linux on it. Like, no, this is proper old computer.
1995. It is a DX4. Oh. It says on the chip. What is that? That is a 486, isn't it?
Yeah, what is that? Is that one of
AMD's? Before the Pentiums. Cripes.
Oh yeah, Intel DX4. Yeah, 486.
Man.
Oh boy.
Yeah, you don't want to use that as your daily driver. Except that it's awesome.
You open it up, show them the keyboard, and then put it away.
Yeah, it is cooler if it works, though. I'll give you that.
Oh, with a blistering 32 megabytes of RAM, too.
Well, I am on some kind of a retro kick. My next hack, the clock, another way to modify the sound of a synth chip, is a dive into kind of an old school circuit bending. For those of you kids out there, people back in the early 20 teens used to take apart electronic musical instruments and like screw around with them all on the inside and see what kind of horrible noises they could make them make. And this was circuit bending, and it was really fun and really interesting because you could do a lot of it without deep circuit knowledge, but of course then the more you knew about how the synth or cheap toy worked, the better chances you had at making it misbehave in an interesting way. In this case, he's not even opening up a synthesizer. Volkert van Heusden is taking the chip, the Philips SA1099, which was the chip out of among other things, an old Sound Blaster, I think the Sound Blaster 1 card, and playing around with it. And in particular, what he's doing is he's driving its clock at different speeds and seeing how that glitches it out. And the answer is really amusingly. You should listen to some of his audio files to see how that happens. But I think one of the things I really like about these super old sound chips is how kind of monolithic they are. Like, this is just a dip chip. You put it on a breadboard or whatever, and you feed it data over its data bus, and it gives you crazy synthesizer sound out the other side. And that's just, I don't know, it's just marvelous to even think of a day when that was a reasonable thing to do. You get this, like, of course you get 8-bit sound out, right? But that's kind of cool in and of itself. And what before was you have to interface this with a computer is these days, of course, any old Arduino will work. So that also makes this kind of poking around at these ancient sound chips a lot easier. He initially thinks about using a clock generator chip, but then decides he's just going to spit out a square wave straight on out of the Arduino. He actually is off by a factor of 2. He's aiming at 8 megahertz and then realizes that he was kind of plugging it around in the 2 megahertz to maybe 4 megahertz range. And so not running it at all as fast as he should have, but a lot slower. And maybe that explains some of the creepy glitch noises. He also like speeds the clock up and slows it down. It's really fun.
I like in the write-up where Jenny was like, well, duh. Like, obviously changing the clock frequency would have an effect on the pitch. Like, that seems kind of, elementary, but she makes the point that like when this came out, doing this arbitrary frequency would have been a lot harder to pull off, at least, proper equipment. Now, like you said, we just grab a whatever microcontroller happens to be laying on your work surface or floor, and you can make a square wave out of even if you're off considerably, like he was here, you'll still at least get the desired result, and you can move it around and see what happens. Whereas that would have been a considerable trick in the 80s, right? Unless you had like a function generator. Even that would be pretty high frequency function generator.
Function generator, yeah.
Yeah.
What are you, a millionaire?
Yeah, right. I like unless you were working for NASA or something, you probably didn't have access to it. So it is really cool where you can take these new techniques and fiddle with these old components in new ways. I like your definition of circuit bent too, because that's exactly how I would have put it too. Like, fiddle around in something until it makes a weird noise and done. That's basically it. You add some buttons on the outside so you can hopefully repeat weird noise, and you're off to the races. I think there's probably few other hobbies where I guess it's like the video version of that too. We've seen that before.
Yeah.
Like, they take old game consoles and because they do weird stuff. Like, there's different layers of like the graphics thing, so you can like cut a wire and Mario will disappear, but like the background will still be there and stuff like that. But I think those are probably the only two things where you just intentionally break the device, but not entirely, right? You only want a little bit broken to get the desired effect.
I went looking back on Hackaday to see if I could find a good guide to circuit bending, and January 11th, 2011 by Joseph Thibodeau is Intro to Circuit Bending. You should check it out. It's actually totally legit today. I mean, part of the problem is even the cheap toys you pick up at like the Goodwill or whatever, these days a lot of them have a chip blob on them instead of
Oh
all these
yeah.
discrete parts. And this sort of thing gets a lot harder to do. But even so, if you can find some old gear that has, points you can touch around on, it's really kind of, it might be fun to try doing this sort of thing again. In this write-up, Joseph is taking kind of a disciplined approach to things. He's figured out, how the keys trigger and where the timing circuits are and stuff like that. But some of these old things just have like an RC oscillator as their main clock, and those are dead easy to change the value of. If you just put a big value potentiometer across it, you can twist it and change the frequency on the fly. That's a really fun trick. Another one that I used to play around with is you don't want to short anything directly because, you can burn it out. But if you take an alligator clip and you clip a resistor of kind of medium value to the end of the alligator clip, and then you can just poke around anywhere on the board with that and see what kind of crazy noises you get out. And that's kind of fun too. Anyway, I just think circuit bending is, well, I don't know. I don't know if it's still so relevant anymore, but it's a kind of a fun, goofy thing to do if you happen to find a broken or almost broken or not entirely valuable toy that you want to open up and play with for a day or two.
All right, well, my next one is lessons learned, plastic injection molding for products. Injection molding is one of those things where it just always seems out of reach for the home gamer, right? I mean, now we have the benefit of desktop 3D printing, so it's not as big a deal, I suppose. But, there's always like, you must be this high to ride to do injection molding, because it doesn't make sense unless you're going to do a bunch of them, and you're probably not doing a bunch of them if it's a personal project. So it was always this kind of thing that was just a manufacturing technique that was interesting, but not super applicable to our kind of stuff. But it is getting cheaper, like everything else. There are overseas companies now that will offer these services to you at sharply reduced rate compared to what legacy people. But it's still hard, and it's still something that you don't want to get into without some decent knowledge. This is a really cool write-up from the Air Gradient project, which incidentally, I don't know how we haven't written up yet. They appear to have open source kits for air quality monitoring, which seems really cool. But anyway, they needed a bunch of cases, and so they went down the injection molding route with a company in China, and it really gives a cool firsthand look at how you go from design to a case in your hand, and the pitfalls and the different steps of the process. And there's some they drop some terminology here that you may not have run into before, where they say like the T0 sample, where it doesn't have all the outside textures necessarily, and it probably won't have any of the details, but it'll have the right shape. Your PCB should still screw into it, and it should be structurally sound and that kind of stuff. And if you're happy with that, then it would proceed to a T1, and the T1 looks much closer to your final product, so there's different stages of it. And one of the things they do recommend is just paying a consultant, and there's certainly the appeal of trying to do everything on your own and save money, but they make the point here that the consultant will more than pay for themselves by addressing difficulties in manufacturing that you might not, especially if you've never done it before, you might not notice. Stuff like where the mold lines are going to be, and making sure that you don't have a 90-degree angle because like the plastic won't come out. There's stuff unique to injection molding that, and if you haven't done it before, you won't know. And rather than having a bad time or getting a result that isn't what you hoped for, cough up some extra bucks and hire a mold consultant. And they even go to the lengths to mention, like, hey, if you're looking for somebody, email us, and we got some names for some experts that you can talk to. They didn't put their names on the article itself, but they said, touch base with us if you want to hear our mold guy.
Yeah, I'm looking at this case here, and it's an incredibly complicated part. Got like cable routing cutouts, and it's got air holes, and it's got those little keyholes for mounting on screws and stuff. I cannot imagine trying to make the mold for that thing, because it is like a really complicated part. And I'm glad that the person who made this is writing it up, because this is the part that you will definitely have trouble with when you try to get it made. And it's really cool. They've got an animated GIF of a fluid simulation where they
Oh yeah,
pump the
yeah.
plastic in and they watch it spread out through the mold. And you can kind of see how it has to, wiggle around some of the zones where the surface isn't regular and stuff. And it does make you wonder. It definitely makes you think about the intricacies of the design and how to pump the plastic in there. Then all of a sudden, it does seem like it makes a lot of sense to get a consultant in there to check it out for you beforehand. Because if you're paying 5,000, 10,000 bucks for a mold, you're going to be a sad, sad puppy if it doesn't work, right? So get that thing to work first and get someone who knows what they're doing. That said, there are like people who do kind of small scale. For instance, the precious plastic people do injection molding, and I know a lot of model makers do small scale injection molding. And in fact, on this very badge for Hackaday Supercon, we've got a custom injection molded joystick button on it. And they've got apparently over at Design Lab in Pasadena a small injection molding setup. And I haven't seen it. And I am dying to give it a look in person. These buttons are really sweet. They feel really good. It's got a little Jolly Rancher, in the thumb button. It's pretty sweet looking. And it fits like a glove on that little stem. I mean, it was custom work.
I had assumed it was resin printed, but now that I'm looking at it,
I believe that Giovanni Salinas is over there at Design Lab pumping these out as we speak.
Well, that is pretty cool. Well, you know what they say. When you have an injection molder, everything looks like melted plastic. That's a phrase they say, right?
They say that a lot. All right, my next hack is a dirty hack. It's a video on computer file, full self-driving on a budget. And this is definitely, do not do this at home. I mean, the only thing that's nice here is that the person doing the work actually didn't do this at home either. This is making your own self-driving vision routine in principle. And, to me, this looks like an academic computer scientist slash mathematician slash I'm not 100% sure what, who is designing his own neural network self-driving car for fun. And the good news is that what he's doing, instead of getting out there in a dangerous vehicle that's going to drive him into a guardrail, is that he's gotten in his car, he's done a drive that he knows well, he's recorded video, and at the same time in parallel, he's recorded his steering wheel inputs through the ODB connector. No, I said it wrong. Through the onboard
OBD.
diagnostic, through the OBD connector. And he's using that input to then train a neural network based on the image it sees and the steering wheel input to do that same drive for him. And so basically he's doing kind of this one drive over and over again, and he's training the neural network to do that. And I think that's kind of an interesting problem, but I think it way underestimates the problem of a self-driving car. And, this is one of those things where in theory, everything's fine, but in practice, like nothing is the same as it is in theory. And so, what can I say? I really will say don't do this at home unless you have a padded road to try it on or something. I don't know what. I do think it's a really neat experiment to see how far you can go with A, just a camera, and B, like the simplest training data possible to see how far that'll get you. And his conclusion is it actually gets him pretty far. The problem with driving a car is that it doesn't have to get you pretty far. Like 99% of the time you don't die isn't good enough, because that means 1% of the time you end up wrapped around the guardrail, and that's not cool. It needs to be like 100%, but out to like how many, hundreds of thousands of digits or something. I mean, if you think about me, I probably have, what, 300,000 miles of driving experience, and I've had one accident, and that was back when I was 17 and stupid, frankly, under my belt, right? Like, so that's a lot of miles to be not having any sort of problem. And this guy's doing like this little 20-mile drive to his dad's place. So, there are scales and there are scales. On the other hand, it's really pretty cool just to see, how far you can get with kind of the naivest possible approach to the problem.
Well, this next one I thought was really cool. It started as a pandemic project and just snowballed on from there. This is a solar camera built from Raspberry Pi, and back in 2020, Will Wang was stuck in quarantine and said, you know what I want to do? I want to take pictures of the sun. Sure, why not? So came up with a Raspberry Pi based like solar tracking camera and got some pretty cool results. And so was born an obsession. And now, a couple of years and several $1,000s later, he has a much more capable setup, and now has spun that off into like 2 open source sensor projects for collecting light at different wavelengths and all kinds of stuff. The current version of the hardware is based on the Pi 4 compute module, and when you read the write up, your first thing is like, wow, Pi 5 would have solved some of these problems. So, and he kind of actually acknowledges that. He's like, yes, I know the Pi 5 would have given me stuff like the PCI Express easily accessible and stuff like that. He had to use the compute module to break that out, and it seems like probably the future will be the Pi 5. But hey, he did it with the compute module and came up with like his own board for it, and a lot of really cool details in here. I think one of the more interesting kind of segues while he talked about building this thing is that you need a lot of high resolution images very fast, and then you then take them and like stack them up, come up with like a final composite shot. As probably anybody who's tried to like do a file server or something on the Pi knows, there's some pretty serious bottlenecks in terms of file access, and it's not exactly an ideal platform for a bunch of high resolution pictures at multiple frames per second. So he went around for a couple different ideas, and he was going to do an NVMe over USB, but then USB is the bottleneck, and then he got to the point where he said, okay, I'll do the compute module, so I'll have PCI, and then I could do storage over that. But he wanted, and I'm not super clear why this was necessary, actually, but he wanted hot plug. He wanted to be able to take the drive out and replace it, which you can't normally do because the Pi doesn't support that over PCI. But then he figured out that you can do it with Compact Flash Express, which is a new flash format that some like the high-end cameras are using. So he was able to do like PCI to Compact Flash Express to NVMe, and he has these like custom drives basically where it's like this 3D printed frame, and it has like the Compact Flash Express thing in the front, and then it adapts it to an NVMe, and he can just stick these things into the side. It's a really cool storage solution that I don't think I've ever seen before. And he mentions it was maybe more work than anticipated, but it does get him where he wanted to go in the end, so you can't complain too much.
Wow, what blew my mind about this project was the custom cameras, essentially. Like, he bought a camera sensor. I'm looking in particular at his 1-inch eye, which is the big sensor that he has set up. And he basically designs his own camera board around an IMX 283 sensor, which is a big, he calls it the 1-inch eye because I guess it's a 1-inch diagonal. It's a pretty big sensor. And he's got the data sheet for it and designs his own camera board for it. Now, this is something I had no idea was within the realm of possibility for hobbyists at all. But if you want to see what goes on behind the curtain there, you absolutely should. This is really an amazing piece of work and engineering here.
And one of the things I thought was interesting too is that, to be clear, like, all this is just on the camera side. You know, it still then needs to hook up to a multi-$1,000 telescope. You know, this is just you know, this is just the camera. So if you think, oh, okay, that's not bad. You know, a couple grand and I'll be there. Like, no. That's literally just a fraction of the total package here. You know, he's just doing the image sensing, although it does also automatic tracking, because it's doing like computer vision, and it's got stepper motors hooked up to the mount and also like the focus, so it can track the sun while it moves. I mean, but the telescope itself is its own very expensive off the shelf piece of hardware. So this is like astrophotography too. I mean, it is a serious hobby. Like, make sure you set aside some money before you go down this road.
For quick hacks, I'd like to start off with high SPL low-cost mic preamp. This is a suite designed by FV Filippetti. The trick here is, if you have a cheap Electret mic, they're really great for making recordings, except they distort at high volumes. He's got an innovative circuit here with an op-amp in feedback that keeps it from distorting if, say, you're going to try to record a rock concert. Next up, Bone Shaking Haunted Mirror uses stable diffusion. What is AI image generation good for, if not a Halloween scare? Tim implements it here by using the image-to-image function. So it takes a picture of you on one side of the mirror, makes a creepy version of it, and then displays it through the other side of the mirror with a monitor, like those magic mirrors. Next up, Tom Stanton's maybe last video in his now 6-year project to make a compressed air airplane, stretching the flight time on a compressed air plane. What he did here, after years and years of working on the motor, was he kind of optimized the heck out of the air motor to recreate an air hog, and then basically discovered that making a good airplane will make the thing stay in the air longer, and experiences tremendous success. Which I could have told you just should have made a better airplane.
Yeah, right?
It's not the motor. If you have a strong motor, anything can fly. But if you have a crappy motor, you have to make a good plane.
Yeah, what the Wright brothers were using, like a 4-horsepower motor or something ridiculous.
And GVL 610 makes the world's slowest Linux computer even slower than Dmitry Grinberg's version of this same computer that he did a long time ago with an ARM chip. Basically, you emulate a RISC-V chip, and then you boot a Linux that boots on the RISC-V chip onto the device. All the memory is off board, and that is definitely the bottleneck. I think the thing boots up in like 17 days. But you can type on it, and it's a full Linux, not a micro Linux, a full Linux on an Arduino Uno, emulating a RISC-V.
Well, my first quick hack is memorialize your favorite chips in Slate. This one comes from the why didn't I think of that category for sure. Jason Kuhn, who was inspired by posts on Twitter, to be fair. Apparently, this is an idea that's been floating around. He just kind of ran with it. He takes a laser and commonly available, 4x4-inch Slate coasters, and then slaps on the chip art from your favorite piece of silicon. And it looks phenomenal. He's got a whole gallery of things, up to 140 something chips he's done now. Everything from, modern ESP32s back to, 486 and all that. Much easier to get square pieces of Slate because, as I said, they sell them as coasters, but you can also get more rectangular ones. So he does have like Intel 8086 and the 555 timer are even represented. So if you have a laser and you don't know what to do with it, you can pump out your favorite chips from today or yesteryear and build yourself a little collection. Next up is, can an 8-bit light gun work on a modern TV? And I think we all kind of know the answer is no. At least not, stock. And if you haven't been around long enough to experience a light gun for the old consoles, it was kind of thing like with Duck Hunt, where an annoying duck would fly and you'd shoot him, and a more annoying dog would laugh about it. The Post is interesting because it goes into the how that these light guns worked. This is 80s technology, so it was pretty simple for the Nintendo Zapper. You literally just had a light sensor and a trigger that told the console when to read from it, and you got effectively a 1 or 0 if it was pointed at something white or if it was pointed at a darker color. And using some software trickery, when you pulled the trigger, a white block would come up over the thing you were supposed to be shooting at, and it was only there for a frame, so you wouldn't necessarily see it, but the console could detect that you were pointing at it. The problem is with modern TVs, well, one of the problems is that there's lag in the image processing. So the white box shows up, but it's late, and the console doesn't know what to do with that information, so it just assumes you missed. The short version, though, is that it is possible to patch the games to take this delay into account. It's not easy, and frankly probably more work than is really worth it to play any of the light gun games from the 80s, but if you know that delay and can predict it, you actually can patch the ROMs and still use the light guns, which is pretty cool. And lastly, even 3D printers are taking selfies now. This is about doing time-lapse videos for 3D prints, which are pretty common. If you ever go on, the 3D printing subreddit or something, you're going to see people with these magical videos where a benchy just sprouts up from their build bed. I think it's fair to say most people would be doing Octoprint and using one of the plugins for that, and they would be running it on a Raspberry Pi, and they'd be using a USB webcam. I think you could probably make the case that that's your boilerplate setup. And that's all fine, but USB webcams are notoriously not great. And we have these super high resolution cameras in our phones, and most of us have phones just laying around. So the idea came to Matt at GemRise. Why can't I use my phone for that? So he came up with this whole setup where he's using a Raspberry Pi to emulate a Bluetooth keyboard, which then pairs with the phone and takes control over it to take the pictures, and then the pictures are collected and processed. It's a very sprawling project that has many different aspects to it, but the end result is that you can use whatever old phones you might have, and this is also whatever operates it. It works on iOS and Android, which is really cool. So it's definitely something to keep an eye on. This is not a technology that would even necessarily be limited to just 3D printing. I mean, the idea of remotely commanding the phone with the Pi wirelessly is pretty cool. So I'm really interested in seeing this project kind of cross the finish line and see what else people might come up with using these techniques.
All right, that brings us to our Can't Miss articles. These are long-form pieces written by our own fantastic Hackaday writing staff. And this week I want to pick up Arya Voronova's USB-C for Hackers Build Your Own PSU. And that's because this is a super ambitious project she is embarking on. Arya's written up a lot of her previous deep dives into the USB-C and USB-C power delivery standard before, and that's because it's a really neat way to get a whole bunch of voltages out of kind of a single smart wall wart. And that's useful by itself. If you want to adapt a project of yours to plug into an existing USB-C power supply, you have to buy one of these trigger boards, and it's got some brains in it that negotiate with the power supply and make sure it gets the right voltage. What she's working on is taking something like an old laptop power supply, an old laptop 20-volt power supply, and making the smarts in it to make that thing act as if it were a USB PD power supply rather than a device that's consuming it, but, an actual supply itself. And so this is kind of the other side of the USB PD negotiation from what she was looking at in her previous article. This is really cool because if she can get this project to work out, it will give your old laptop power supplies kind of a new lease on life. By just building the circuit, soldering it in, boom, you've got a USB PD power supply. And if you've looked at 20-watt PD power supplies, they're actually kind of expensive. So this is also a really cool thing to do just from a budget standpoint, but also gives you something to do with all of those old laptop power supplies you've got kicking around in your closet. She goes a little bit into USB PD here, but you should actually read her previous one about programming the PD transactions if you want to get deep into that. But the basic story is you plug it in, it supplies 5 volts, and then the device and the power supply communicate with each other. The device asks for 20 volts. The power supply says, okay, I'll give you 20 volts. And then boom, it switches over to 20 volts on the same line. And that part of the circuit she's got working with a kind of complicated MOSFET circuit to do that switching. Like I say, this project isn't done yet. I think she's got the plans and she's got a prototype board and she's been working on it, but it is not finished yet. I'm hoping this is going to be a 2-part article series, but we'll see. Depending on what pitfalls she runs into in the next one, it may be a 3 or 4-part series. We'll see what happens. I am pulling for her because if she can get this board designed and if it works well enough, I've got a bunch of old laptop power supplies in my closet that could see a new lease on life.
I think that's really the takeaway, right? We all have a bunch of old power supplies that need to do something, but you hate to throw them away, even though everything else is moving to USB-C. I know, personally, I think at this point, everything I have, maybe?
Oh.
Everything modern I have anyway. I still got a couple old machines kicking around, but it is remarkably convenient to have all your devices charged from one cable. Surprise, surprise, right? Like, what a incredible concept! Not having to have 6 different chargers. I mean, really, all of her work with USB-C has been phenomenal. Done several posts now. It's one of those topics where it seems like there's no bottom to the rabbit hole, because everyone just goes deeper and deeper into it. But they're all very applicable information for us, right? I mean, if you're making gadgets now,
I mean, the one thing that's interesting about the PD standard is that it's got all of these different voltages that you have to be able to supply if you're a variable voltage power supply. I think it's like 5 volts, 9 volts, 15 volts, and 20 volts. And the rules say if you offer 20, you have to offer 9 and 15. And the experiment here is going to be if you only have a 20 volt laptop power supply, or God forbid you have one of those that's for the European market that was designed to get, there was some law where 20 volts and above fell on one regulatory category and under. And so we have all of these power supplies that are like 18.9 volts or 19.4 or whatever the heck they are. So it's going to be interesting to see how tight the tolerances are on all of this stuff. And if she can get away with supplying 19 volts when 20 is asked for, et cetera, et cetera. It's going to be some good fun. It's definitely going to be hacking and most likely not USB PD compliant. But that's not the point. The point is getting this thing working. And that's what I want to see her do. So encouragement, go, go, go. Get this thing done. I can't wait to see the next article in the series.
Well, my pick for a can't miss article this week was an easy one. It is the long-awaited reveal of the 2023 Hackaday Supercon badge. I would have to say, I think this is going to be unexpected. We've kind of come from several years of very computery badges. Literal computers, right? Going all the way back to like the basic badge, and then the FPGA, and then of course Voya's 4-bit badge. I mean, they were all about as digital as you can get, and this is kind of a step in a different direction. This is I think as you describe it in your article, it's sort of analog. It's fakes analog convincingly, and the idea here is that you have a oscilloscope and a function generator on one badge. The oscilloscope comes complete with the glorious phosphor effects of yore. None of that modern digital oscilloscope LCDs. Although, of course, it is realistically a round round smartwatch LCD. No CRTs we can put into an event badge yet, as far as we're aware. What I think is really interesting about this is that, behind the scenes, there's a Pi Pico running everything. So the oscilloscope and the function generator are ultimately the same device. But the way it's been implemented here is that there's a row of pins along the side. One is the output for the signal generator, the other one is the input for the scope, and you actually have to physically jump them with little wires, and I think it brings a cool, I don't know, like a visceral thing where you have to have this little plug board and actually, jump wires to get a signal from A to B, even though ultimately being handled by the same, internal electronics. But I think it's cool. It really kind of simulates this impression where like you have two pieces of gear on the bench and you need to hook them together, or hook something in between them, which is also, I think, something that is very interesting here, is that the badge has a sort of sidecar proto board that can bolt on, that gives you a prototype area as large as the badge itself. It literally doubles the size of the badge. And whatever you want to put there that can sit in between these two devices. Talk a little bit about that in your write-up. Synth circuits or whatever to play with the signal and generate different things. It does, the badge makes sound also, so you can generate waveforms and listen to them. And I think it's going to be really cool. I think there's going to be some very unexpected applications for it. I mean, I guess that's kind of goes without saying for one of these event badges, right? That's sort of what we always shoot for, but it's going to bring people out of their comfort zone, which was sort of a theme that I think we run with more often than not. And not to say it's always worked out, but it certainly worked out last year where, people came in and maybe they weren't familiar with like bare metal programming or working on such a constrained system. And I think they walked away with a new respect for that, a lot of them, and some of them an interest. I know personally after, spending some time with last year's badge, I, got real interested in like, doing a 6502 computer or something like that, and messing with more, assembly. So I think that there's certainly the potential here for analog electronics, and I think that's going to be kind of cool, where you're going to have people who come in and, maybe they've never messed with this kind of thing at all. Maybe they never even, saw a CRT oscilloscope to get the joke of the phosphor, effect, but they're going to experience it at Supercon, right? And they're going to hopefully come away with a new respect for that and learn something. And if we're really lucky, they'll create something cool that we all get to marvel at the badge competition on Sunday.
I think we got no problems here. I think a lot of people are in their comfort zone with oscilloscopes. I don't know how many people out there have played around with oscilloscopes in XY mode, though, which is kind of what this thing is doing. You know what it does. More voltage makes it go more X. More voltage on the Y pin makes it go more Y, and it draws. How hard is that? But we'll see. We'll see. No, it was super fun to design, and it's a little bit of an exercise in silliness because, like you said, the voltage generator is connected to the scope by nothing by default. You actually have to run a jumper wire there, and that's because there's a DAC and an ADC, and so the arbitrary waveform generator is really making an arbitrary waveform, and the scope part is really responding to these fluctuating voltages. And so that was kind of the idea of breaking this out with voltage in the middle, was to let people play around with voltage control and see what they can do to mutate the signal. But like it also lets you make things like an old school curve tracers. You could see what the like current versus voltage curves look like for, I don't know, transistors, diodes, all sorts of fun things like that. I mean, the other thing that's super fun with the badge is just to program fun looking graphics onto the screen. And it's kind of a weird way to do it because you're not like doing a raster scan where you just say, here is, a series of points. I want all these points white. Here's a series of points. I want all these points black. Instead, you're saying, I want the point whitener to go to this coordinate and then to that coordinate and to that coordinate. And that's that kind of old schooly vector graphics programming is going to be fun and interesting. And we'll see. On the one side, it's kind of partly more intuitive and easier to say, wiggle this point around the screen. And on the other hand, it's harder to draw things that you may be thinking of from your kind of raster graphics perspective. So like you say, it's gonna push people 90 degrees into a different comfort zone, I hope.
Every year, I'm always amazed. We could give them a cardboard box and tape, and they could probably.
That's right.
Last year, especially, I can't even express it. You just if you're not there in person to see the badge competition, at least watch the stream, because you give this group of several hundred very creative people a badge, and you give them a bunch of components, and they really just run with it, and everybody has their own little interests and the knowledge they bring to the table. And of course, there's also a lot of it's a social aspect too, because maybe you have only part of the puzzle, right, but the person sitting next to you has the rest of it. So it is not uncommon at all to see the badge hacking become a very communal effort.
For sure. And my hope on this one is that, some people just explore the fun Lysijuice figures space, or, just do something simple like programming, I don't know, funny trefoils, or, repeating graphical patterns into the MicroPython interpreter, and just have fun with the kind of scopiness of the badge as it is. And then other people try to do things like, like make a scope clock or whatever else. And then other people try to do, fancier things, like you said, with games where there's some actual programming logic behind everything, as well as just, fun eye candy. It's funny, I was talking with my wife about kind of the history of badges, and she's like, why are you even doing this? And I'm like, well, it goes way back. And that's like, well, I mean, DEF CON started it by having people wanting to sneak into the very expensive conference by faking badges, and then making unforgeable badges in response to that, and then upping it by making unforgeable badges with an electronics component that ostensibly made them harder to forge. And then the electronics part of the badge took over its own life, and now there's absolutely no authentication function of this badge left over. You could fake this badge and we still won't let you in. You have to have a ticket to get in.
Yeah, right.
You don't have to have a badge anymore. And so it's kind of weird the way the whole thing has metastasized. Like, I don't think there's any space on this for you to put your name except the screen, maybe.
Oh, yeah. Right.
Somebody's going to figure out a way to write their name on it. It doesn't serve the authentication purpose. It doesn't serve the identification purpose. What's badgy about this badge anymore? And the answer is nothing. It's just something cool that everyone can play with.
It's hard to imagine upping last year's badge in terms of stuff per, square centimeter, but there's a lot of stuff on this one. There's not there's not a flat spot to be had on the whole badge. Everything's a button or a header or an LED or something.
So that part of it is Voya's design. I basically gave him this kind of idea and some rough circuit diagrams, and my whole this works on the breadboard, now make it into a physical thing. And Voya took it from there, and I mean, A, totally ran with it. It's awesome. But B, just because of the layout and because it wanted to look like one of these old tech scopes, he put some buttons down, and he's like, oh, we have more space for buttons. We'll put more buttons and more LEDs. And he's just fitting everything in there. So like you said, it's pretty dense. But there's one button in there, and it's the user button. And he put that in there just for aesthetics and for symmetry. And for the longest time, we couldn't even think of what we were going to do with this button. And it was labeled question mark, question mark, question mark. And there were 2 revisions of the silkscreen for which the user button was just labeled question marks. We're we just can't do that. What's the user button going to do in the final firmware? I don't know. We'll just call it user. And so that's what we went with. And 2 weeks out, we still don't know what the user button's going to do. And I think, frankly, the user button is going to be entirely up to you. It's the user button. That's all we got for the Hackaday podcast this week. Thanks very much for listening. If you want to follow along with the links, head on over to hackaday.com/podcast. And if you see anything cool or do anything cool, send us an email, tips@hackaday.com. And until next week,
Keep on hacking.
good to go.
All right, we cool with that one?
Poke around in there.
As one does, right?
You could laser off the epoxy blob.
We'll cut out the parts where I can't think of simple words, right? What is the word I'm trying to think of? I know this word exists. I know. I think I had a stroke. Okay.